All right, class, great job. You've made it through to the last section in statistics, section 9.3, and this covers measures of regression and prediction intervals. So in this section, we talk about the variation about a regression line. And there are three types of variation about a regression line. There's the total variation, which includes explained variation and unexplained variation. So to find the total variation, we need to know the total deviation. And then to find the explained deviation, to find the explained variation, we need the explained deviation. And what's left over is the unexplained deviation. So let's start with the total. So to get the variation about a regression line, we need the total deviation, which is the observed y minus the y bar, or the average of the y's. So if I had 6 values, then I would have y1, y2, y3, y4, y5 by 6. So those would be each of the 6 values that we observed, or the values from the data for y. And I would take each of those values and subtract off y bar, or the mean of those 6 values. So I would end up with 6 differences. Okay, so that's how I get the total deviation. And then the explained deviation, I use yi hat. So this is the predicted value of y for the matching x value. So if I have 6 values, I would calculate my my regression line, y hat, and then I would take each of my x values. So I would put x1 into that formula and get the y1 hat value. And then I would put x2 in and I would get the y2 hat value, and so on. So I would have 6 of these y hats, and for each of those, I would subtract off the average y value, the mean of the y's, y bar, and that gives me my explained deviations. And then my unexplained deviations are the difference between the observed values, yi, and the yi hat. So this is the one that I get from the regression line. So again, I would have 6 of these. So I would take each value and subtract off the regression line. And I want you to recall this value here, yi minus yi hat. So that is our residual, right? Because this is your y value minus your y hat. Okay, so here is our total deviation, which is our yi. Look here. Here is a value xi, yi from the data. And then here is the mean value. This one is, this is for that x value, xi. This is the yi hat value. So again, this is my observed value, and this is my value for xi, comma, yi hat. So the xi and then the predicted value. And down here, here's my y bar. So this is my average y value here. Remember, it's going to be on the regression line, because the point where y bar is on the regression line is x bar. X bar, y bar is always on our line. So this is the point x bar, y bar. So this is yi, comma, yi bar. And so this would be xi, our xi, right? And then our yi bar. Sorry, this is our x bar, y bar. This is our xi, yi bar. I think I said that wrong. Anyway, so to get these deviations, the first one is yi minus y bar. So here's my yi, and here's my y bar. So it's the difference between these two values. This one is yi hat minus y bar, yi hat minus y bar. And this last one is yi minus yi hat, difference here. So the way that we find it is the total variation we find by using the sum of squares of the differences between each y value and the mean of y. That's the total variation, the difference between the yi value and the mean of y. Same way that we would calculate a sum of squares for any variable to calculate the deviation, right? We take the observed value minus the average, square it, and divide it by n. For the explained variation, we use yi hat minus y bar, the sum of yi hat minus y bar squared. And for the unexplained variation, we use the sum of yi minus y hat squared. And the sum of the explained and unexplained variation is the total. So the total variation, so if I add these two variations together, I will get back the total. So the explained plus the unexplained equals the total, which also means if you have the total and you had one of these, you could get the other one by subtracting. And the coefficient of determination is r squared, and r squared is the explained variation divided by the total variation. So again, r squared is the explained variation divided by the total variation. And this is our correlation coefficient squared. So this is the same r that we did in 9.1 squared. So that value squared is the definition of that is it's the explained variation divided by the total variation. Okay, and then we have our standard error of the estimate, which is the standard deviation of the observed values about the predicted values for a given x value. So this is denoted by SE. So it's the sum of yi minus yi hat squared divided by n minus 1, because these are our degrees of freedom. And the closer your observed y values are to the predicted values, the smaller that your standard error of the estimate will be. So again, so the better that the regression line fits the data, basically. So the closer the observed values are to the predicted values, the smaller the standard error of the estimate will be. So I'm going to show you guys how to calculate this in Excel because it is much easier to do in Excel. But I just want to remind you that the regression line, we use y hat equals mxi plus b. Okay, if you want to do this by hand, you would have to create a table with all these things. So you would have to, in addition to having your xi, yi, and all the things that we did before, you would need to add a yi hat column. So you would put in this formula and you would find the yi hats for every observed value. And then you would get these differences. So you can get the standard error of the estimate. Okay, and we don't cover prediction intervals in our textbook, so I'm going to skip that part. So let's go look at the homework. So I thought I had the homework open, but let me open it again. Okay, so the only things from this section are number 11 and number 12 in our homework. So number 11, they give us a the value of r. It's a little bigger. Let me also open up my Excel spreadsheet. Here we go. Okay, so for this problem, oh, I'm having an issue here with Excel. Move this over so you guys can see it a little better. All right, so they gave us R. So use the value of the linear correlation coefficient R to calculate the coefficient of determination. What does this tell you about the explained variation of the regression line? So remember, the coefficient of determination is R squared. R squared is our coefficient of determination. Okay, so to calculate that, we're just going to square R. So I'm just going to add this to my Excel spreadsheet. So the coefficient of determination, I like to just abbreviate. So this is R squared. Okay, so if they give us R, minus 0.058, then my coefficient of determination is R squared. So this is what I put in. Make that red. Okay, and then so I go equals this squared. And so round to 3 decimals, 0.003. Okay, what does this tell you about the explained variation of the data? So remember, the coefficient of determination, R squared, which is the mean variation divided by the total variation. Okay, so that's what this is. It's my explained over my total. So what does it tell me about the explained variation? It tells me that 0.3%, so just converting this to a percent, which I get by multiplying it by 100%, 0.3% of the variation can be explained by the regression line. Okay, so if 0.3% of the variation is explained, that means okay, so I'm just going to take this number and rewrite this as a percent. So let me make this to 3 decimal places just to make my life easier. And then let me make this one a percent. So I'm just going to change that to a percent and make it to 1 decimal place. All right, and then my unexplained is just 1 minus this, right? Because the explained and the unexplained is the total. So it means 99.7% of the variation is unexplained. So I recommend putting this all in so you have it in Excel, and then you have what it is. So when they ask you this on a quiz or a test, actually there's no quiz for Unit 5, when they ask you this on the final exam, you'll know how to get this. Okay, So use the value of the linear correlation coefficient to calculate the coefficient of determination. And so this is the same thing. So you can just change we can just copy this. 12. And now I just went Control C and then Control V, minus 0.098, and it'll calculate things for me again. So the correlation of determination is 0, 1, and 1% is explained by the regression line, and 99% is due to unexplained. Okay, and that is the end of the section. But I wanted to also show you, I mentioned it before, but this R squared number, so if they have you do a regression, this R squared number that it gives, that is this R squared. So even though this shows up as a capital, that's the same thing as this. And so if I needed R from this, I could just take the square root. So this is R squared. So if I wanted to get R, I can take the square root. So in this problem, 95% of the variation is explained by the regression line. Hey, congratulations. That's the end of the homework, at least.